Ulrike and Ambrosio and Joseph talk about how a lot of the math curriculum still is based on these ideas of mercantile mathematics, economic use of mathematics, that are situated in capitalism, in colonialism, right? I love elementary math, I love operations, but this focus on addition, subtraction, multiplication, division, right, has roots based on a mercantile way of looking at the world. That the world is about being able to do marketplace math, quick, right? Being able to figure out what you're buying and selling, right? Situating all of us as consumers, right? And so we can also sort of think back, like, you know what? A lot of us don't like math because we don't like multiplication, or because we've had issues with division that are difficult. And in fact, that's not all math is, right? Like Nathan was saying, that's actually problem solving. But a lot of times math in our school curriculum is situated as just these isolated skills, right? And Michel Gutierrez positions mathematics and knowledge, right, as often white, middle-class, Eurocentric, right? We don't call it geometry that's filtered through a Greco-Roman Eurocentric lens. We just call it geometry. And yet, there's a lot of historical evidence in mathematics that other ways of thinking of geometric principles existed in ancient Egypt, existed in ancient China. You know, the Mayans, you know, were building amazing structures. And yet, we're still focused on, you know, Euclid and Pythagoras' ways of looking at geometry, right? So how do we move past a mathematics that just doesn't operate within this Eurocentric space? The second thing, framework is listening, right? And this is something that Dr. Susan Emerson taught me, is the power of mathematics teaching is in being able to recognize their children's unique mathematics. And for those of you who are in pre-service teaching programs right now, I'll tell you the secret to this, right? Listening is really hard. I'm about to enter my 10th year of marriage. Every single day of my life, I'm learning to listen better. And it's going to take me like probably another 100 years before I actually know what I'm doing, right? It's really hard, right? Right? Every decision we make as educators of our students has lifetime repercussions, right? So Robert Berry talks specifically about our work with other students, you know, whether they're Latinx, whether they're black, whether the students who are some way minoritized in Montessori. How do we work with them? How do we listen to them? How do we get ourselves into their minds so that we can see their excellence, right? Robert asked, you know, what does black success in mathematics look like? His work is primarily about black students, right? It's really, really hard. There's a study that came out from Johns Hopkins that said, you know, most teachers who are not black have a really hard time recognizing giftedness in mathematics of the black students, right? It's hard for many teachers to get past those racial boundaries to see that someone is mathematically brilliant if their skin tone or their background is somewhat different than their own, right? That's a problem, right? So how do we connect? How do we connect to the community math, the cultural math, the math that we know our students are doing, the math that they're doing at the store, the math that they're doing at the house, the math that they're doing at the laundromat? How do we connect that math that they're rich in, that they know, to the mathematics that we do in the classroom, right? So there's three types of listening. The directed listening, which is the listening that I sort of do when I'm listening for the right answer, right? This is the way I taught math, right? Where, you know, a teacher would say, hey, go to the board and write the answer, and I write the answer, but they're just checking to see if I got it right. Or they're just checking to see if my strategy is the same as what they did, right? There's observational listening, which is a little bit more intense, where you're just really trying to understand the situation, you're paying attention, right? There's those things that sometimes we tell our students. Those of you who have ever been in a KIPP school, right? I teach the students, like, look, make eye contact with the teacher and nod along, right? So it's easy to fake listen, right? Okay, I do it all the time, right? Yeah, I can totally hear you say, right? And then I do it, I repeat the thing. Hey, you're talking about this, right? And I think as teachers, it's easy to sort of pretend, right? What we want to move to is responsive listening. We're really putting ourselves into the minds of our students. And that's really hard to do. I think that's a crucial aspect of that work, right? We need to listen to know who the child is in all aspects of the world. Not just who they are in our classroom, but who they are at home, who they are in the community, who they are outside of our classroom, outside of our realm, who they could be, their potential, right? How do we listen for that? So, this is one of my favorite images. This movie I made my kids watch it a few times. Does anyone know where this image is from? Yeah, one that said Hidden Figures, right? If you haven't seen Hidden Figures yet, you have to see it. It's so good. The book is actually not as good as the movie. I hate to say it. I love the book, but the movie so. But so look at the image, right? And what do we notice about this image right away?
There's one person that stands out.
There's, like, your eyes sort of focus on this one anomaly, right, in the image, right? She's right in the middle. She's wearing a different color. She's a different gender, right? She's a different ethnic and racial identity, right? And yet she's part of the club, right? She's part of that group of mathematicians, computers, right, in the world. And I think what this movie impact, even for us who work in math ed, is the story of black computers and mathematicians who work deeply as part of the space program that I had never heard of in my whole life, right? And I've been studying math education for years, right? So I want you to turn this on, right? You thought about the child that you work with, right? So talk about with your partners here, right? What does it mean to do math? Particularly, what does it mean to do math if the child you're working with is black, Latinos, gay, trans, other? How do they think about mathematics, right? You try to pull yourself out of deficit ideologies, but really put yourself into their shoes. What is it like for them? So go ahead and talk about each other. These templates of who is and who isn't math, right? They're integrated not just in what we frame math, but even also in the teachers, right? And how our teachers present and situate themselves with us. So the third part of what I want to talk about is creative insubordination, right? And this is a framework that Theodore Chao has talked a lot about, and Rochelle Gutierrez. How can we connect traditional lessons so that they involve issues of equity, right? So Paulo Freire, right, in pedagogy of the class, talk a lot about how young children are really good at recognizing injustice. And I know this, those of you who have kids, right? I have 3 kids, they will tell you when something's unfair, right? The other day, I only had $6 in my wallet. All 3 kids wanted Happy Meals at McDonald's. McDonald's Happy Meals are $2.99 right now. I could only afford 2 for my 3 kids. It was a bad situation. They immediately, like my 4-year-old was like, there's not enough money for all 3 of us. 4, right? And so, what we do as adults, right? We often dismiss children's voices if things are unfair. It's easy for us to brush things off as complaining about things, right? But when children use mathematics, right? Like when my daughter says, hey Dad, there's 3 of us and there's only 2 kids meals, I'm going to claim one of the toys, right? If she already makes that decision, it's like, it's not fair, right? It's not, like I already am engaged in the mathematical thought because she's brought it up, right? I could have very easily been the dad who pretended I don't know what's going on. Oh no, we only have 2 Happy Meals, I'm sorry, right? But I can't get away with it because deep down inside I know that it's unfair. And it's because the children bring it up, right? So, how do we do this, right? How do we creatively insubordinate, right? So that we can use the curriculums that we're locked into. We can use these standards or these curriculum guides or these lessons or these structures within our school that we have to teach in order to create lessons that are equitable, in order to create lessons that connect to community knowledge, and help all of our students, not just our white male students, right, or our Asian male students, or our students who already have a lot of confidence in math, but all students feel like they're part of this mathematical lesson. Right? Invite them all. So, I want to show you I want to show you some work that I've done in Columbus, Ohio. So, I'm going to show you a video. This is a pre-K classroom. Kids are 4 years old and 5 years old. And as I show this video, I want you to think about how many empty seats do you see? And so this is about Rosa Parks. We all know who Rosa Parks is, right? Very classic lesson in civil rights history. Rosa Parks sat on the bus. Outkast made a song about it. Right? How many people have to stand back with us? Is this fair and why? And how could you take this framework, what we're seeing here, and turn it into a math lesson? Right? How could you introduce the math into it that is connected to how children think? I'll show you the Rosa Parks reenacting, sitting on a bus, right in the front of us.
Like the bus, it's not a penny to ride the bus. I'm sorry, sir. You're going to have to go roll back. You're going to have to go roll back down. Sir, I'm going to need you to, if there's no more seats, I'm going to need you to stand up back there. What seems to be the problem on the bus?
So do we see? Look at almost every seat, right? It's a dramatic outcome. And then look at all the children who are standing in the back with no seats. These poor 4-year-olds, right?
Oh, with brown skin, African American skin, have to sit where? So, was it fair that white people got to sit on the front of the bus and because your skin was brown, you had to sit at the back of the bus? Was that fair? Now, I need you to go to the back of the bus.
I will. You see this question, right? So we saw some empty seats, right? We saw some people standing in the back, right? For the children, do you think they recognize the unfairness of the situation? Right? Immediately, right? They talked about it. So how can we make this mathematically simple? So, I have some sheets. Can I have somebody help me? Oh, I faculty help. Thanks, Bill. Thank you. So, I'll have to say, as Corey and Jen are passing these sheets, we did this activity again. So this was a classic activity that happens in almost every classroom in the month of February, right? Sometime during Black History Month, there is a reenactment of Rosa Parks in the classroom. We see this all the time. How can we take these lessons, right, these historical lessons, and connect deeply to issues of civil disobedience in math, right? So D'Angelo Jones, the presentation you see there, and I thought about how we did this, right? And then I don't have a video of what it looks like, but I'll show you what our students did. So when we did this again, where the focus was on using math and using numbers to show you how it's unfair, right? You saw that in the first time the kid says, there's a little boy that says, it's not fair, it's not, right? The second time when the answer said, let's use numbers. The student says, it's not fair because 8 children were standing and 12 seats were empty. There's more about it, right? Immediately are mathematizing why this is unfair, right? And so with that, right, all of a sudden as an adult, it's harder to dismiss that second sentence because there's some logic behind it. There's some mathematical logic that we as adults, as mathematical people, have to pay attention to, right? Something there is not right. And so you saw that when the children got on the bus, they each put a little coin, which is a little bank. That coin represented a dime, right? Back when this happened, right, it cost a dime to ride a bus in the country, right? And so D'Angelo walked the children through these exercises. It cost 10 cents to buy a bus, to ride the bus, right? 10 cents, each had to put 10 cents in. Now the boycott starts. Let's open up the bank and let's count one to one of all the students who are not riding the bus now the boycott starts, right? How much money the bus lose? Right? This is a great lesson for the pre-K students, right? 4 or 5, we counted, by tens, right? 10, 20, 30, 40, 50, count how much it costs, right? Then they counted, well, when I'm riding the bus, I'm riding the bus to school. I also need to ride at home, right? So now, how much money does the bus lose on a daily commute to school or to work for each person, right? And then looking back, like how many times does the bus in your neighborhood go around on one day, right? We found out the bus can only ride about 13 times around the neighborhood in one day, right? 13 rounds. So how much money does it lose when people aren't riding the bus anymore, right? And then we took this into we took this in a third quarter classroom. And we said, okay, so at the time, 40,000 of the daily Montgomery bus drivers were black. And these were the people who participated in the boycott. How much money did the entire system lose each day if those people were no longer riding the bus? Once, twice, sometimes 3 times a day, right? And then we had the students really break it down. Okay, so this is a lot of money, right? So go ahead. I'm going to ask you now. You have the worksheet in front of you. Feel free to write on it. The workout lasts 381 days, which is still shocking that it lasted for so long. How much money did the system lose during the entire work? Right? Take a few minutes now. Do you have calculators? If you want to Google how much $956 are, or $2,070, how much money did the Montgomery bus accounting system lose during this workout? Go ahead, write up. What will you